Alright, so this is both sections 1.2 and 1.3. Should be able to put these together in one class, in one sitting. Remember, there's, especially early on, there's a lot of this stuff in Algebra 1 that you've definitely seen before, that you could definitely just describe as we're reviewing it, or just trying to make sure there's no misunderstandings and that we're mastering this material once and for all. So we're talking about in 1.2 adding and subtracting rational numbers. Remember what rational means? So basically any number you can think of, including decimals like 5.9, so these are nice round numbers, or I should say whole numbers or integers, but also included in the rational numbers are numbers that are not integers, basically, in like 5.1 and stuff like that. So remember, and furthermore, the only numbers that are not rational would be numbers like pi, or the square root of 2, or the square root of 3, or the square root of 5. Those numbers are irrational because they have decimals that not only go on forever, but they go on forever seemingly at random, and there's no infinite repeating pattern. So anyway, just again, in conclusion, not to repeat myself too blatantly here, but so we're going to be dealing with numbers that are not square roots of that, like ugly square roots, or numbers like pi. And then I think 1.3 is going to be multiplying and dividing, if I'm not mistaken. But let's get started. No more messing around. So I have a number line right here, okay? And when you're adding or subtracting numbers and there might be negatives involved, or you might get a negative answer, it sometimes helps to kind of picture the number line, or at least understand what's going on with the number line and negative numbers. So if you are adding a number, like if you're adding a number to 2, what direction are you going to be moving? Like if you're adding 10 to 2, where are you going to end up? More to the right or more to the left when you're adding? You're going to go to the right, and that stays the same if I said, okay, what's negative 4? And then we're going to add 10. What direction are we going to move? We're going to move to the right 10 spaces. And if we add 10 to negative 4, that's only going to get us to positive 6. So negative 4 plus 10 equals 6. Okay, so again, think of it as when you're adding, you're almost making a move to the right. So likewise, or conversely, or whatever, when you are subtracting, you're moving where? So if you were doing like 5 and then you were subtracting like 5 minus 2 or 5 minus 9, right? Where are you moving? Are you moving to the right or to the left when you subtract? And I hope you're immediately thinking, we're going to move to the left. 5 minus 2, you move back to 3. Or 5 minus 9, you go back to the left like 9 spaces, and you end up at negative 4. Okay, so other than that, to start us off, the whole like when we're adding, we're moving right, and when we're subtracting, we pretty much kind of move left, number line wise. I think the only other thing I'll say to kind of build a little jumping off point or a foundation for us in this lesson is it helps to think of it as money. If you have $5 and you lose $6, you know, somehow, or you owe somebody $6, right? And you're only starting off with $5. You know, what's 5 minus 6? That means you are like in the hole $1. Okay, like you have negative $1. Or maybe you can think of it as temperature. You know, if it's very cold outside and it's really only 5 degrees, but then the weather person says that, oh, over the next 24 hours, you know, we're gonna like drop another 6 degrees. From 5 degrees, we're gonna lose like 6 more degrees. And so if we're at positive 5 and we're going down by 6, well, we only have like 5 degrees to lose. So if we subtract 5 from 5, we of course end up back with like nothing, with 0. But if you subtract 6 from 5, you end up just a little bit into negative land. Likewise, if you're sitting at like negative $3 or negative 3 degrees and you gain $5 or 5 degrees, you know, the first $3 lands you back to 0, but since you're adding 5, you end up 2 places into positive land. Anyway, enough really about that. So again, I'll keep the number line here on the screen. So just some repetition here. It's also worth saying right now that you're pretty much always going to have a calculator handy. You know, if you need, if your mental math is failing you at the moment, you know, and again, everyone has their own limit of mental math. I have my own limit of what I can do in my head. You have your own limit of what you can do in your head. Some people might have a more or a higher capacity than me for mental math, some people less, right? So you always have a calculator if there's any doubt of doing this stuff in your head. But I think you should at least, you know, even though you have a calculator, you should understand what adding means. And not to skip ahead too much, but what subtracting a negative number means, or adding a negative number, you know. So there's a few more details here to review, but so here we go. So 3 plus 4, 3, and then we're adding 4. You know, I think most of you, if not all of you, know that that's going to be 7. And then 9 plus 13, right? We're getting bigger, yeah? And then 6, and then we're adding 8. You end up at 14, right? So here on the next row, we're adding a negative. So what does it mean to add a negative? And I don't know if I'd like to write this down. When you add a negative, you're essentially just subtracting. So to add a negative 4, it's literally the same as just straight up subtracting 4. Adding a negative 4, subtracting 4, same thing. So negative 3, so again, here's where your mental math hopefully is up to the challenge here. If you're at negative 3 and then you subtract 4, you're going to the left. You're going deeper into negative land, and you end up at negative 7. Just like here, like if you're essentially doing negative 9 minus 13, you're getting bigger into negative land. Negative 6 minus 8, you wind up at negative 14, right? So it's more the same. 3, what's 3 minus 4? If you have 3, you know, you could think of it as when you were in maybe first grade or something, and your teacher was like, if you have 3 apples and someone takes away 2 apples, or if someone takes away 3 apples, well, here, if you have 3 apples and you lose 4 apples, you're into, you know, negative land. 9 minus 13, you have 9 apples and you lose 13 apples. You're a little bit into negative land, right? And then once again, Adding a negative 8 is just like subtracting 8. Nothing that new here. If you're starting at negative 3 and we're adding 4, that means we're going to the right. We're heading towards positive land, 4 places, okay? Negative 9 plus 13. What's negative 6 plus 8? And then last thing to point out here on this slide is, what does it mean to subtract a negative number? Like, how do you do 3 minus negative 4? Like minus 4, okay? These might be blank for some reason, if I remember. But I think this one has got something that hopefully you can write down. So if you have 2 minuses, if you're subtracting a minus, that's the same as just adding. So like minus 8 is literally the same as just adding 8. So this ends up being 14. So this one, 9 minus 13, you might as well think of that as just 9 plus 13. And then likewise, this one, should write this down, minus 4, that's just equivalent to just plus 4. And so 3 minus 4, same as 3 plus 4, 7. Okay, I think this is a just sort of a like a repeat note from section 1.1. So our previous lesson, the lesson we just got done, I think we mentioned what an opposite is. So here we go. The opposite of a number is its, maybe this is like a slightly different vocabulary note here. So it's again, it's also concerning opposites, but this is new, where we can actually refer to an opposite as an additive inverse. So they kind of just mean the same thing. So the opposite of 4, what's the opposite of 4? We talked about this last section. Negative 4. So in other words, we could say that the additive inverse of positive 4 is negative 4. And here's a question that might at least challenge you a little bit, you know, might stimulate your brain a little bit. What is the sum of a number and its opposite always equal to? If you add up a number and its opposite, or a number and its additive inverse, you're always going to get what? 0, of course. And so that's the first half. Because the next half is technically we're going to call section 1.3, multiplying and dividing with rational numbers. You know, essentially we're focused on, you know, negatives. Like if we're including negatives in all these operations, multiplying and dividing, what do you have to remember about that? So negative numbers really being the big focus. So 3 times, again, mental math, right? Hopefully your mental math is up to the challenge here. Otherwise you are a little bit handicapped with just everything we're going to be doing and you're going to be doing after this class is over. Just all the different skills and concepts and types of problems. If you can't do stuff like this in your head, you know, it's not the end of the world, because again, calculators exist. But just trust me, it's good to make an effort to what's the word, remedy any, you know, shortcomings you have with some of these times table facts. You know, 3 times 2, well, 6. That's like second grade, right? 5 times 7. What did you learn that was in like second grade? 35. And then division is just sort of like the, I don't want to use the word opposite, you know, too sparingly or willy-nilly, but, you know, division's like the reverse, kind of, or the opposite of multiplication. So it's 12 divided by 6. 2 and 9 divided by 3, 3. Okay. Now, there is something else to say about this row, but as I do that, let's look ahead to the other rows. Because in this row, we're essentially going to be talking about how what happens when you have one of the numbers positive and the other numbers negative. You know, one of the numbers positive, the other numbers negative. Negative, positive, same thing. Or what do you get when you do a negative number times another negative number, or a negative number divided by another negative number? Okay? Because obviously, so going back up to here, if you have two numbers that are positive, I mean, you never quite talked about this in second grade, but if you have two numbers that are positive and you multiply them together or you divide them, your answer is also positive. So 3 times negative 2, when the signs are different, your answer's negative. When one of the numbers positive but the other number's negative, doesn't matter if you're multiplying or dividing, your answer is negative. Which again, just like I mentioned at the start of this video, this shouldn't be news to you. This is something you've definitely heard at least once before in your life. So down here, what happens when you have a negative times a negative, or a negative divided by another negative? Well, you can kind of group it in with this. When the signs are the same, whether it's two positives or two negatives that you're multiplying or dividing, the final answer is positive. So this will make positive 6, multiply together to make positive 35. These two numbers divided to make positive 2 and positive 3. So there should be some space somewhere, I would think. I mean, you don't need a whole lot of space to write down these two notes. I mean, whether or not I don't know if I left you like a big chunk of space. Yeah, it looks like I did. There's definitely a bit of space here for this note. So we just said this, but let's write it down. If the numbers have the same sign, the number is positive. And if the numbers have different signs, the number is negative. So pause the video if you have to finish writing that down, because I'm going to move on. Here's another property. For every non-zero real number, not to over-explain this or over-teach this, but just remember, when we use the word real number, now that includes both rational numbers, all the rational numbers, you know, and rational numbers can get a little crazy, but real also includes irrational. Remember, irrational gets really crazy, like square root of 2, and remember all those never-ending, non-repeating pattern decimals. Okay, but anyway, for every real number that's not 0, we're just going to call it A, whatever, variables, but so we're just going to use A as like this just general variable to describe like any potential, you know, real number that's not 0. There is a multiplicative inverse, which we're going to call 1 over A. So whatever number you're talking about, whether it's 5 or negative 2.3 or square root of 10, you know, or pi, whatever, it doesn't matter. For any real number A, just not 0, there's a 1 over A, which we can call a multiplicative inverse, such that if we multiply them together, again, whether it's like 5 times 1 over 5 or negative 3 times 1 over negative 3, what do you always equal? Oh, good Lord. So I said, what does it always equal? 1. Examples. You know, I just said 5 and negative 3. But here's some other examples to write down. 6 times, so this would be like the let's lock that in. So 6, and this would be its multiplicative inverse, or if you're thinking of the word reciprocal, you're not crazy. I think we're going to actually write down that word in a later section that's coming up pretty soon. So this would be called its multiplicative inverse, or reciprocal, and it equals 1, of course. And then, remember, A is anything rational or even irrational. So look, 3/5 times, oh gosh, why is this so, what am I locking in here? I'm losing momentum here, man. What the heck? Sorry. So what I maybe should write down here is, where did 5/3 come from? 3/5, wouldn't it be times 1 over 3/5? Yeah, but guess what? 1 divided by 3/5 is 5/3. And when you multiply these together, you get 1. And holy moly, that's it for 1.2 and 1.3. Thanks for following along.